In this session, we are going to see the Boolean algebra. So what is Boolean algebra? It is a set of laws and theorems used to simplify the switching functions or the logic expressions. It is named after the mathematician's name George Boole, who developed this algebra in 1854. And Boolean algebra is used only when the number of variables are 3 or less. If it is for more than 3 variables, it will be very difficult to simplify it using the Boolean algebra. Then we have to go for another method known as map method that we'll discuss later. Now we will see the fundamental postulates and theorems of Boolean algebra. The first one is complement law. So complement law is nothing but it states that A complement the whole complement is equal to A. That means if we complement a number, binary number, twice, that will give the same answer as it is. That means we can prove this by taking A equal to 0. If A equal to 0, 0 complement the whole complement. What is 0 complement? 1. 1 complement 0. So 0 complement the whole complement is equal to 0. If A equal to 1, 1 complement the whole complement. What is 1 complement? 0. 0 complement 1. So 1 complement the whole complement is equal to 1. So from these two we can understand A bar the whole bar is equal to A. Now we have a set of rules with respect to an AND operation. AND operation means multiplication operation. So the first one is A dot A is equal to A. A dot A is equal to A. So we will see the proof of that. If A equal to 0, if A equal to 0, 0 dot 0, 0 into 0, 0. That means the same A we are getting at the answer. If A equal to 1, if A equal to 1, 1 dot 1, the answer is 1. Again, answer is same as the A variable. So from this we can conclude that A dot A is equal to A. Same way the next rule is A dot 0 is equal to 0. A dot 0 is equal to 0. Again, if A equal to 0, 0 dot 0, 0. That means 0. Answer is 0. Same way, if A equal to 1, 1 dot 0, 0. So whatever, whether it is 1 or 0, if you are multiplying with 0, the answer is going to be 0. Next is A dot 1 is equal to A. A dot 1 is equal to A. Again, we'll see the proof here. A equal to 0. If A equal to 0, 0 dot 1, 0. That means A. Again, if A equal to 1, 1 dot 1, 1. Again, that is A. That means A dot 1 is equal to A. If you multiply any variable with 1, the answer will be the same variable. Now the next rule is A dot A bar. A dot A bar is equal to 0. We'll see the proof here. If A equal to 0, if A equal to 0, 0 dot 0 complement. What is 0 complement? 1. So 0 dot 1 is equal to 0. We got the answer as 0. Now if A equal to 1, if A equal to 1 again 1 dot 0 equal to 0. How are you getting 1 dot 0? 1 dot 1 complement. 1 complement is 0. So the answer is 0. So whatever A dot A bar is equal to 0. Now we have a set of rules with respect to OR operation. OR operation means logical addition. So the first one is A plus A is equal to A. A plus A is equal to A. We'll see the proof here. If A equal to 0, 0 plus 0, 0. If A equal to 1, 1 plus 1, 1. So if we are adding the same variables twice, that means A plus A, we are getting the same variable A. Next is A plus 0 is equal to A. A plus 0 is equal to A. Here also we'll see the proof. If A equal to 0, 0 plus 0, 0. We are getting A. Again, if A equal to 1, 1 plus 0, 1. Again, A value. So the A plus 0 is equal to A. Next we have A plus 1. A plus 1 is equal to 1. If you are adding 1 to any function, any variable, the answer is going to be 1. Here, if A equal to 0, 0 plus 1, 1. If A equal to 1, 1 plus 1, 1. So whatever A, if A equal to 0 or A equal to 1, the answer is going to be 1. Then we have A plus A bar is equal to 1. A plus A bar is equal to 1. If A equal to 0, 0 plus 0 complement, that means 1. So 0 plus 1, 1. If A equal to 1, 1 plus 1 complement, 1 complement is 0. So what will get 1 plus 0? 1. So the answer is 1. Now we have the next theorem, distributive law. So distributive law of Boolean algebra is A dot B plus C is equal to A dot B plus A dot C. How we can prove this? With the help of a truth table, we can prove that. In LHS, we have what? A dot B plus C. And how many variables are there? A, B, C. 3 variables are there. So we are taking the 3-bit combinations from 0, 0, 0 to 1, 1, 1. Then we are writing all these A, B, C. For the LHS part, first we want B plus C. So we are finding out B plus C. Then we want A dot B plus C. So A dot B plus C. This is our LHS. Now for the RHS part, first we want A dot B. That is why we are finding out A dot B or AB. Then we want A dot C. So that we are finding out here A dot C. Then we want A dot B plus A dot C. So A dot B plus A dot C. And then we have to show this LHS is same as the RHS. So these are the 3-bit combinations: B plus C, 0 plus 0, 0, 0 plus 1, 1, 1 plus 0, 1, 1 plus 1, 1, 0 plus 0, 0, 0 plus 1, 1, 1 plus 0, 1, 1 plus 1, 1. Same way, this should be multiplied with A. We'll get this answer. Then we have to go for A dot B, A into B. We need to do the multiplication, write it here. Then A into C, multiply it and write here. Then A dot B plus A dot C, we are getting this answer. And if we compare this A dot B plus C with A dot B plus A dot C, we can understand both are same. So this is the proof of the first distributive law. Then for the second distributive law, what is that? A plus B dot C is equal to A plus B dot A plus C. Same way, with the help of a truth table, we can prove this also with 3 variables. That means 3-bit combinations we need to take. Now the next theorem is commutative law. So commutative law is what? A plus B is equal to B plus A and A dot B is equal to B dot A. So Boolean algebra also satisfies the commutative law. Next we have the associative law. What is associative law? A plus B plus C is equal to A plus B plus C. Same way, with respect to an AND operation, we can write A dot B dot C is equal to A dot B dot C. This also we can prove with the help of a truth table by taking how many variables? 3 variables are there. So we need to take 3-bit combinations from 0, 0, 0 to 1, 1, 1, and we can write LHS and RHS accordingly, and we can show that LHS is equal to RHS. Now we have an important theorem, absorption theorem, which will be used for the simplification of Boolean functions very often. So in absorption theorem, there are 2 theorems. In the first one, A plus AB is equal to A. And the dual of this is what? A dot A plus B is equal to A. How we are writing the dual? Plus should be changed to dot, dot should be changed to plus, and if there are any ones, we should write it as 0. If there are any zeros, we should write it as 1. That we'll see later. So anyway, the first one is A plus AB is equal to A, and the second one is dual of this is what? A dot A plus B is equal to A. We'll see the proof of this. How many variables are there? Only 2 variables, A and B. So we can write only 4 combinations, 0, 0, 0, 1, 1, 0, 1, 1. Now for this first one, what is LHS? A plus AB. So first we need to find out AB, then A plus AB. Then for the RHS part, what we have? A. So that we can write it from here, A. So what is AB here? Multiplication, 0 into 0, 0, 0 into 1, 0, 1 into 0, 0, 1 into 1, 1. Now A plus AB, A plus AB. A is what? 0, 0, 1, 1. This A plus AB. So 0 plus 0, 0, 0 plus 0, 0, 1 plus 0, 1, 1 plus 1, 1. Now if you compare this A plus AB with A, you can understand both are same. A value is 0, 0, 1, 1. A plus AB is also 0, 0, 1, 1. So this is the proof of the absorption theorem. A plus AB is equal to A. Same way we can prove the second one also. This is A dot A plus B is equal to A. So for this also, for the LHS part, first we need to find out A plus B. Then we have to find out A dot A plus B. And then we need to show this is same as A. So A, B, 2 variables are there. So 0, 0, 0, 1, 1, 0, 1, 1. Then A plus B is what? 0 plus 0, 0, 0 plus 1, 1, 1 plus 0, 1, 1 plus 1, 1. This is A plus B. Then this should be multiplied with A. So 0 into 0, 0, 0 into 1, 0, 1 into 1, 1, 1 into 1, 1. Now you see what is A dot A plus B values? 0, 0, 1, 1, which is same as A values 0, 0, 1, 1. So this is the proof of the absorption theorem. A plus AB is equal to A and A dot A plus B is equal to A. Now the second set of theorem in absorption theorem is A plus A bar B is equal to A plus B and A dot A bar plus B is equal to AB. Again, this is the dual of this theorem. A plus A bar B is equal to A plus B. How we can write the dual? A, in place of plus we need to write it as dot. So A dot A, here it is A bar dot B. So here we should write it as A bar plus B is equal to A plus B should be written as A dot B. So these are the 2 sets for the absorption theorem. Now we will see the proof of this theorem. Again, 2 variables are there. So writing only 4 combinations, 0, 0, 0, 1, 1, 0, 1, 1. And for the LHS part, we want A bar B should be added with A. So first we are going to find out A bar. Then we will multiply A bar into B. Then we will find out A plus A bar B. then that should be same as RHS A plus B. So writing A plus B. So first we'll find out A bar. What is A value? 0011. Complement of this will be A bar. So 0011 will be 1100 here. Now this A bar should be multiplied with B. So what will get in A bar B? 0 into 1, 0. 1 into 1, 1. 0 into 0, 0. 1 into 0, 0. We got A bar into B. Now this A bar into B should be added with the A. So tell me 0 plus 0, 0. 0 plus 1, 1. 1 plus 0, 1. 1 plus 0, 1. So we got the LHS values as 0, 1, 1, 1. Now what is the RHS of the theorem? It is simply A plus B. So these are the A and B values. How we can write the A plus B? 0 plus 0, 0. 0 plus 1, 1. 1 plus 0, 1. 1 plus 1, 1. Now compare these two columns. A plus A bar B is 0, 1, 1, 1. A plus B is also 0, 1, 1, 1. That means LHS is equal to RHS. A plus A bar B is equal to A plus B. Same way, with the help of a truth table, we can prove the second theorem also. So now we will see an important theorem of Boolean algebra, which is De Morgan's theorem. So two equations are there in De Morgan's theorem. The first one is A plus B the whole bar is equal to A bar into B bar. A plus B the whole bar is equal to A bar into B bar. And the second theorem is A dot B the whole bar is equal to A bar plus B bar. We are converting this OR operation to AND operation and AND operation to OR operation. So A plus B the whole complement is equal to A complement into B complement, and A dot B the whole bar is equal to A complement plus B complement. Now we will see the proof of these two theorems with the help of a truth table. How many variables are there? Two variables are there, A and B. So we need to write the 2-bit combinations, 4 combinations, 0, 0, 0, 1, 1, 0, 1, 1. Now what is there in the LHS part? A plus B the whole bar. For finding A plus B the whole bar, first we will find out A plus B, then A plus B the whole bar. Then for the RHS part, first we will find out A bar, then B bar. Then we need to find out A bar dot B bar. And we need to show LHS is equal to RHS. That means these two columns must be same. So 0, 0, 0, 1, 1, 0, 1, 1. What is A plus B? 0 plus 0, 0. 0 plus 1, 1. 1 plus 0, 1. 1 plus 1, 1. Now A plus B the whole bar, complement of this, 0 complement 1, 1 complement 0, 1 complement 0, 1 complement 0. So A plus B the whole bar values we are getting it as 1, 0, 0, 0. Now for the RHS part, we are writing A bar. A bar is what? Complement of A. 0, 0, 1, 1 is A. The complement will be 1, 1, 0, 0. Now B values are 0, 1, 0, 1. Complement of B will be what? 1, 0, 1, 0. We got 1, 0, 1, 0. Next, we need to multiply these two, A bar into B bar. So 1 into 1, 1, 1 into 0, 0, 0 into 1, 0, 0 into 0, 0. Now check the LHS and RHS. It is 1, 0, 0, 0 and RHS is also 1, 0, 0, 0. So this is the proof for the first De Morgan's theorem. Same way we can prove the second De Morgan's theorem also. A dot B the whole bar is equal to A bar plus B bar. Again two variables only, 0, 0, 0, 1, 1, 0, 1, 1. For the LHS part, it should be A dot B the whole bar. Then for the RHS part, A bar, B bar. Then we need to add these two, A bar plus B bar. So what is A dot B the whole bar? Multiplication and then complement. So 0 into 0, 0, 0 complement 1. 0 into 1, 0, 0 complement 1. 1 into 0, 0, 0 complement 1. 1 into 1, 1, 1 complement 0. This is the LHS part. Now for the RHS, first we are writing A bar, which is 1, 1, 0, 0. For 0, 0, 1, 1, it is 1, 1, 0, 0. Now the complement of B, it is 0, 1, 0, 1. Complement of this will be 1, 0, 1, 0. Now we are going to add these two. So 1 plus 1, 1, 1 plus 0, 1, 0 plus 1, 1, 0 plus 0, 0. Now you check the LHS with the RHS. It is 1, 1, 1, 0. So here also we are getting 1, 1, 1, 0. So LHS is equal to RHS. So this is the proof for the theorem A dot B the whole complement is equal to A complement plus B complement. So now we will see the duality theorem. So duality theorem states that starting from one Boolean expression, we can write another Boolean expression by following these three steps. So the first step is change OR sign to AND sign, change AND sign to OR sign, and complement the zeros and ones in the expression. That means OR sign means if it is plus, change to dot. If it is dot, change to plus. If there are any zeros, change to 1. That means complement of 0. If there are any ones, change that to 0. That means complement of 1, 0. So by following these three steps, we can write one Boolean expression from another Boolean expression.